Hi, and thanks for watching another instructional video for CSCI 1300. In this video, we're going to be talking about class hierarchy and how that relates to your final project. So what is class hierarchy? Class hierarchy becomes important when we start dealing with multiple classes that are related to running a program. In the context of a game, we might have classes related more to storage or aspects of the game that we want to represent. For example, if we were to try and represent a chess game, we would need a board with a series of locations on that board, and each of these locations would be unique, and we would have to keep track of them. So each one of these locations that we have here would be part of a larger collection of the whole board. And that means that we would have to have a class for each individual location and then have maybe a collection of those class for locations. So we could have a class for the tile or a location class related to maybe like putting something on the board at a given index in a storage pattern like an array or something. And say we wanted to represent something like, say we have like a chess piece or something that we need to represent, and we need to place that on that location. Well, we wouldn't actually place it on the location, but we could represent it and make it move to a location and have its grid location be expressed as something that could work with a tile. So we'd probably have to have a separate class for the chess piece. For each piece in the game. And if we were to actually run the chess game, we might actually need something to run both the tiles and the chess pieces together. So we might need to have an all-encompassing class to handle both of them, which we're going to call like a board class. So for example, our lower level classes, which are representing aspects of the game, would involve, say, the tile class here, and maybe say the piece class. And so we're going to consider these to be lower level classes because they're aspects of the game that we need to represent, but they're not going to do much for us after we load them up. We need something to actually run both of them and manage them. So that's where we come in with a larger class here, which we're going to call the board. Now the board class is like a game class. It's going to be responsible for the operations of actually doing things with the other classes. So we're developing some kind of a hierarchy here where we have a parent class that is now managing a series of lesser classes called children. So the parent is always managing the child classes. And how is that done? Well, each one of our child classes is included through a hashtag include in our parent class. We might represent that through, so if we have a series of chess pieces and we have a series of tiles related to a single board, then we might have to have, say, an array for our tile locations, an array for our chess locations. And we can store that as private data members of our board class. So we're referencing the tile class and the piece class in the board through hashtag includes for their H files. This allows us to store objects of that data type and encapsulate them within the parent class where they can be managed. And just like previous things like Project 2, where we were dealing with two classes and a driver, we're going to still need a driver, CPP, to run everything, which we're going to put up here above our parent class now. So the parent class is acting as a buffer or a central location for our game to be managed by. And since our board is referencing both of our children classes, we can actually just reference the board class in our driver, and as a result, we will include both of our children classes as a result. So when we reference the board class, we're actually referencing tile and piece because they are referenced here in the board class. And as a result, the driver would have access to the board, the tile, and the piece class. The advantages of doing this is that in our driver, we would only need one board object to run the entire game. And here in the board class, we might have multiple child objects stored in order to accomplish the task of running the game. So now we can really see that there is a class hierarchy here. We have children classes that are related to lower level things in the game, and then there's a parent class that is actually managing those classes and using them to run the game or run the program through a driver. So that's all I've got for this video on class hierarchy and developing your final project from scratch. Thanks for watching and happy coding!